Yeah, let's start. So yesterday we have installed our Kubernetes cluster and we have added our nodes, workers. So you can see these are the nodes. I mean, one is master and one is worker. So we have added, this is now the cluster. So I updated the document and I sent to you in the group. So try to use that to install Kubernetes. So you have to make sure that the node and the master should be ready. Okay. So now let's see. So now it's ready. So sorry, cluster is installed, and of course you have seen the kubectl commands. I mean not fully, but at least how we interact. Right? So like we have a few commands like the first command I would say kubectl version. So kubectl version obviously kubectl version. See 1.29. That's what we have installed. So whenever we use some command, so it will get it get the output from the cluster and it will give it back. So how it will work usually? I mean, how kubectl connects to this cluster? So how it happens is usually this kubectl, whenever we give something, this will get communicated with the API server. With the API server, I told you there is a component API server which is responsible for all the things happening, correct? So even when we execute kubectl, API server is on which will talk to us back. I mean, whatever this output we are seeing, this will be given to us by API server. Whatever the input we give, it will be taken by API server. And how API server gives the output back is there is a file called KubeConfig. Sorry, KubeConfig. This is the file. So when you run any kubectl commands, so this will read the KubeConfig file to find the details about the cluster. So what happens here is, let's say I told you that kubectl interacts with API server, but how does kubectl know what is the API server, what is the endpoint of the API server, how to communicate, and I mean everything. How kubectl knows all this is with the help of kubeconfig file. There will be a file. Let me show you. There will be a folder called .cube. Go there. It automatically creates. I mean, we created .cube directory if you remember after the cluster. And config. This is the file, kubeconfig file. If you observe here, in this kubeconfig file, there will be server cluster details. Cluster detail certificate, cluster URL. This is my IP address, server IP address. And what this file contains is API server address, user credentials and certificate and token for authentication. So when you execute kubectl command, this will read this content from this file, kubeconfig file, and talks to the API server. Where is this API server URL? This one. And then it will communicate with them and it will give the response back to us. Got it? So this kubeconfig file is important in order to communicate with the cluster. Let's say cluster is running here in my Linux machine and I want to access from my local laptop. What would you do is just simply copy this kubeconfig file, whatever the content inside it, store in your local laptop, and with the kubectl we can able to access that from our local laptop. First thing is we have to install kubectl in our laptop, then configure this kubeconfig file. Then what happens? kubectl will use that kubeconfig file to connect to the cluster. Uh, It will work. But all we have to make sure is from your local, you should be able to access the server. I mean, the server where the Kubernetes cluster is running. The communication should be there with your local and server. Then you can able to connect to cluster from anywhere if that access is there. So this kubeconfig file will be created by default. Got it? So let's get a scenario that usually what happens is like in generally in every organization, let's as an example, we have will have a multiple cluster. So let's say this is one cluster for some dev environment, let's say, and there is one more cluster somewhere for QA environment. I want to connect from this machine. What would I do? Same thing. I copy the kubeconfig file from that server, the QA cluster, whatever the server is running, and I'll create a file here, paste that, let's say I'll create some file called, QA config, something, anything, it does not matter, the name, sorry. Now what happens is like, in this QA config file, I'll paste the kubeconfig of the other cluster. And while running kubectl command, I'll pass this path of kubeconfig. When I just use kubectl commands, it will take the default, kubeconfig file path, and it will give the output. What is the default? The current cluster. Let's say you want to pass that QA config file, I mean, to get the nodes, to get the information of that cluster from here. Simply you pass like this. What is the path? Dot cube, like this you'll pass. Obviously now it won't work because the file is empty. What? Yeah, I have to give the correct path here. Wait. I am already in. Got it. My bad. Nothing will come. See, because there is just empty file. There is nothing. So obviously it will fail. I'm just trying to show you like we can connect. I mean how kubectl works. How it authenticate to the cluster using this kubeconfig file, and we can have multiple kubeconfig files from different clusters, and we can able to use them to authenticate the clusters particularly to do any action. Got it? So now since kubeconfig is the default, so we can no need to pass kubeconfig arguments or anything. It will automatically takes the default, you know, kubeconfig file and it will give the output for us. So let's talk about first kubectl, commands. What are the some commands are there? kubectl get means it will get you the information. Let's say whether the application is running or not, whether anything. If you want to see something, get. Get nodes means it will show you the nodes. Obviously, you have seen here. Get some other thing application. Let's say it will show you whether the application, the list of applications like this. kubectl get. Get will just display the information for you, basic information. Kubectl there is one more command. Sorry. kubectl describe. When you describe and some resource, it will show you a detailed information of that particular service. So with the get, what happens? Simply you see the output right here. It's just very basic. Just what is the name, what is the status, and everything. If you want to describe, I mean, you want to know more about this node particularly, at the time you describe it, it will give the more detailed information about it particularly. If you want to, like, uh, see a specific, I mean, information about a specific service or more detailed information about a specific service, you use describe command. Kubectl describe. But first, let's before yeah, sorry, before describe, let's check node. So this is the command. If you type this command, it will show you everything. Now let's say I want to see only particular node. Node slash. See, in this format you have to use for anything. If you want to see a particular thing, node slash. I mean the name, whatever the name, service identifier name slash the name of your uh, the service or your node. You can see whether this the particular service. I mean the particular node here. You are now you are a node. You will remove the get describe, then there is here, see, it will give you whole information about this node, creation, schedule, so lots of things. See, this few system information. See, describe will show you like this. Anything, if you want to see information, more information, detailed information about anything within the Kubernetes, you use describe command. As of now, remember these two commands. There are so many things. Sorry. There are so many commands. We'll use specific commands particularly, but we'll go one by one, don't worry. We'll cover mostly all these commands. But for now, get and describe, because we have seen, we'll be working, we have worked already with these two commands while installing the cluster. So I just want to tell you, there are multiple commands with Kubernetes, sorry, kubectl, where you can able to use to create, delete, restart, obviously, everything. But yeah, we'll solve that one by one. So that's about the cluster, the installation of cluster, what is the what are the components inside it, you know. Now, I mean, how we communicate with the cluster through kubectl. Next, what is the next step? I mean, the cluster is ready now. The next step is deploy your application, run our applications, correct? That's what we have to do. That's what the pending, I think. How to do it. Let's start that. So usually in, let's say in Docker, we create images, obviously, and we deploy a container, right? Correct? That's what we Docker run something. Here also kubectl run is there, I mean, similar thing. But here we don't deploy the application, we don't deploy the container. In Docker, we just deploy the container. But here we don't deploy the container. We deploy something called a pod. So inside this pod, there will be containers. What does it mean is, it's like, just a small pod is like, a small unit within a Kubernetes. Like, where we create a pod in Kubernetes, and inside that, the containers will be created. It can be one container, it can be more containers. The pod represents the containers which are, created within the pod. So now let's say, let me, if you might observe, I get to pods I tried. These are all the pods currently we have somewhere. Forget about where it is. I mean, these things. If you see here, ready, blah blah, something, blah blah, blah blah. These are the containers inside the pods. Because Kubernetes does not understand the container. What is that container means? In his terminology, it will create a pod. Within the pod, we have containers. It can be one container, it can be two containers if you observe like this. It can be one, it can be two. So, one minute, let me just. Okay, yeah. So, what happens here is like we're just creating a pod which is a Kubernetes term, and this within the pod, the containers are getting created. That's why we required the container runtime. I told you, right? Container runtime, that is important because Kubernetes does not understand the containers. It just creates the pods. Within the pod, obviously there will be containers, but sorry, that will be maintained by container runtime. Got it? So that's called pod. I mean, pod. You might have heard not Kubernetes pod, some other pods. Just simply pod. Spray came. No, not this. This vapes. Okay. Then it'll be like, let me see, like this, let's say example. This is the pod where it contains multiple P's, sorry. So imagine that this is a pod. Inside these small P's, these are all containers. We can create one container or more containers inside a pod. So let's say if containers are there inside a pod means, let's say two containers are there as an example. These two containers will share the same network, same storage, same configuration, everything. Even it will have the same IP address also. That's what I mean, same network. So it's like a small package. We are creating a pod and pod creating containers. If required, yeah, you can obviously create two or more. That depends on use case. So these pods usually will be creating in the cluster. These are managed by kubelet, the agent. We create the pod with kubectl and blah blah something like that, and the kubelet agent is the right in the machine that will be created. Got it? So I told you either you can have single pod or single containers or multiple containers within a pod. Got it? How to create the pods then? How? Usually we do Docker run to create a container. Now how to create pod? Same thing. kubectl run command is there. No, there are two ways. One is obviously, this one. With the kubectl run command, we can able to create. Another thing is we write a configuration file will to deploy our pod. That's okay. We'll see both of them. But before deploying it, I told you these are all pods. Get pods. These are all containers only. I mean, we created pods in Kubernetes terminology. We created the pods. Inside that, I told you containers. How do you know it's containers? Just Docker ps minus a. Did I give something wrong? There is no Docker.
No, we have installed Docker in root user.
No, it should. No, it does not work like that. It should work everywhere. What happened suddenly? Did I install? No, it should not. Okay. Docker is stopped. That's okay. So I believe I told you right. We started using container D. Let's try in building the image. Nope. So let's install Docker first. Maybe I missed something somewhere. Mhm. Oh, container D is running, right? So this is conflicting with Docker. So that's why Docker has been stopped until container D is running. So here what happens is container D is the runtime for us in Kubernetes because we have to use that. But Docker also will be running. But I did something, it's not working. But that's okay, it's fine, no problem. So here, so yeah, container D is running, so that will be used as a runtime, the default. So it's fine, no problem for that. So now, what I'm saying is pods. Pods are just creating pods, and they are like creating the containers in the background. Let's see CTR. Okay, is not defined. The hell, it is not showing anything. That's okay. Yeah, sorry. So these are all the containers that which we have, which we usually when we create a pod, internally it will be creating a container. Since these are all the master components and this is the network, this is default. We didn't, sorry, of course, we created these things yesterday, but not these. These came by default. We don't install anything. But now in our case, if we want to run any pod, our own pod, let's say, we can run here. Got it? How to run? kubectl, obviously kubectl run command is there, just like Docker run. We pass the port number, we pass the name, the image, and everything. Same thing. But here we're not creating container, we're creating a pod. Do you remember that? And pod obviously will create a container. Why, you may ask, why can't we just simply create a container? Why to create a pod? Of course, that's what we're doing, but in Kubernetes terminology, as I mentioned, right, there is no concept called container. It's the pod. That's how Kubernetes is developed. That's how it is working. So instead of containers, we are creating a pods. But what is the advantage? I mean, why we need to create a pods? We can have one or more containers within the same pod in the containers. As I told you, I showed you the piece example. It's like a pod, and inside that we'll have multiple, uh, multiple containers, multiple pieces, right? Similarly, like that. So that's the advantage. Now, how to create the pod? First one, obviously, kubectl run command. Kubectl run the pod name. What is the pod name? Maybe Nginx. First, let me see the image. Of course, even though, sorry. Yeah, that's okay. Kubectl run. What's the pod? Maybe Nginx. Image name hyphen image. Nginx hyphen port 80. That's it. This is the command. Or you can add one more thing, hyphen restart. Never. So of course, kubectl run. This is the command. Yeah, kubectl run is the command. Nginx is the name, the pod name that we are giving, and this is the image we told to use. Obviously, port. This is the port which we are exposing inside a container. Do you remember, right? We give two ports, host port and container port, right? Container port to what to use inside the container. Here, this is the container port. The host port we don't give here. That's a different way, I'll tell you. But for now, just the container port. And you want to restart or not? Never. Don't restart it. If it is down, just leave it. That's it. Let's try to run. Pod created. See pod slash nginx. So if you want, I told you, right? If you want to see particular resource, the resource name slash the whatever the name that you gave to the resource. Earlier we have seen like get node slash the node name. Similarly, now get pods. We have to see the pods. It means the containers whatever behind it. So pod slash the name. But first let's see this thing. Get pods. See it's running. Or you can try get PO also. See, one by one running. The container is running. 40 seconds it seems. You want to describe it? kubectl describe pod slash nginx. The name. See, these are all information about the pod. These are the events. What happened? It assigned to some node, some mount to volume set of our kube API access failed something. Or I don't know what is this, but yeah, it's running for now. Pulling image, successfully pulled the image, create a container started. From where it is pulling the image? From Docker Hub itself, obviously, because that's the public. So from Docker Hub. So this is about creating the pods. Let's say you want more information. I mean, you can describe to see more information like this, see, or you can pass like this. I can go wide. It will show you little more details, like which server it is running. Which server means which worker. Let's try this one now. Get nodes. It's running in the worker, not in master. See, if you have multiple workers, if you want to figure out which worker the pod is running, of course you can describe it. It will show here, but instead of describing this -o wide argument, so it will show the information which node it is running. That's it. That's how you create a pod. How to delete it? Simple. kubectl delete. How to delete? kubectl delete pod slash the pod name. Remember that the format I'm using, because node slash something to see a node information, pod slash something to see pod information. Next time there will be some more topic, the topic slash the resource name. So we'll use like this. It's deleted, it seems. Let's try kubectl get pods or POC. Nothing, no resources. Of course, this components are still running. They are not showing me here. I'll tell you why maybe later, not now. For now, we'll concentrate on pod. Okay. So that's how one thing is kubectl run to create pods. Kubectl delete to delete anything, the pods and everything. Okay. Now there is one more way to create pods instead of commands. But here is the command. This is the command, right? The same command we use to run, but we'll store this information in a file, just like a Docker Compose file. Here also we have called manifest files. It can be any file name. It does not really matter really. Anything. Let's say it's an ML file. Can be any name. So what we do is we'll write the file in ML format with all this information. We'll write it. That's called manifest file. So we'll divide manifest file into sections. Don't worry, it will be very easy to write. The first thing is API version. So API version, what is the API version? And what is the V1 I mentioned? So the API version is like, represents the API group. Like let's say which version of the API. We have multiple API versions. We'll see slowly one by one. But this is the first one. V1 is the first API version. So what will happen is like, what's happening is like in this version, in this V1, there are some features available. What are those features is like pods, one of the examples. So Kubernetes released in API version called V1. In that, pods are available. Pods. So that's why API version we have to mention mandatorily. So depends on the service, the version will change, but it's easy to remember. So that the first thing is API server. Next thing is kind. What you are creating, pod, right? So you have to define the kind. So these two are mandatory for each and every thing, whatever we create here. API version and kind. As an example, I'll say kind, of course, you can define what you are creating. Let's say pod, let's say some other thing, ABC. You'll define the kind as ABC. Some other deploy, you'll write a deploy. That we'll see slowly, but this is the one. API version also depends on the resource that you are creating. Let's say I'm creating deploy. The API version will be different. Why it will be different is the kind. Now API version depends on the what kind that you are using. There are versions called V1, app/V1, ktest.io something. There are multiple things. Kubernetes releases these API versions with some features, as I told you, right? So this feature called pod is released in V1 version, is available in V1 version. It's not available in some other version like that. Got it? So API version kind, what you are creating. Next thing is metadata. Metadata, there's some information about your pod, what you are creating. I mean, like the name and everything. So metadata name colon test something as an example. I'll give. Anything, it does not matter. I told you, right? Anything you can give. Don't just give spaces. Obviously, it's ML. And of course, if you remember Docker Compose file, I told you I am just following two spaces here without tab, using the tab because I have to follow that. So this will be the common for each and every file, which covered until here, correct? I'm creating a pod, kubectl run. I'm creating a pod name is nginx, here pod name is test. Now next thing I have to define these things, correct? That's what pending. First section is done, second section is pending. Second section, how we define is, there is something called a spec. Spec means specification simply. So here I'm creating a pod, okay, all good with sorry, I can't mute myself because here the recording will stop, so you have to bear it. Yeah, sorry. So until here we told two things. I want to create a pod. The pod name is test. That's it. Now what are required for pod to run? What are required? Obviously you require the image, you require a port number. This is not mandatory restart or not. Sorry. So you have to, these are the specifications to run the pod, right? Correct. Sorry, it's too bad today. So let's define the specifications here. These we usually call pod spec, pod specification. What you in a pod, what is required by pods. And I told you internally pods create containers. So you are defining these information for to create a container only. Sorry. Sorry. So now define the pod spec specifications. So inside this pod spec, what will be the container information? So there will be heading called containers. Inside these containers, we'll define everything. What is the name of the container? Test I want to give. What is the image colon nginx alpine. What are the ports? Container ports. That's it. So we have two sections. One is information about the pod, what is the name of the pod, what we are creating. Next is, okay, you're creating a pod. What are the specifications for pod? This where we defined everything inside the spec. Got it? Sorry. So inside the spec, we define what will be used to create a pod. So obviously we're creating a container, so we define name, what is it, port number, blah blah, something like that. The same, whatever we wrote in the command, we're just writing in ML format. Remove this line. See, that's it. Of course, the file will increase in future, but for now, this is the thing. Let's save it. Is it clear? I mean, the file is understandable. Before I run this. Is it clear? Any doubts?
So whenever we mention the type or kind of the file is pod, then the API version should be always version 1, right?
It depends on the what kind we are creating. Depends on what kind we are creating. I'll show you a sample, but forget about it now. As an example, I'll show you one thing. I'm just showing you from official document only. See, the kind is deployment something. What is API version? Different, correct? It means this kind, this, whatever this feature is available in this API version. Similar way here also, this kind pod is available in this API version. How do you know? By reading the document, that's it. That's the only way. So, like that, there will be multiple services. We will come to this deployment also, don't worry. But depends on the kind, the API version will be there. Pod is very starting, I think it's a very, the first thing to be, first feature to be available in cluster. So at the time, the version is API version is V1. So that's why we mentioned it. So depends on the kind, the version will change. Got it?
Yes.
So these two will change depends on the, what is it, the kind. This is mandatory, obviously. Of course, the name might change, but yeah, this is mandatory. And there is something called pod spec. We are creating a pod, obviously. Here we define the pod. There will be spec for each and everything. So since we are creating pod, this is pod spec. And containers, of course, that's what we are creating, right? Inside a pod, we are creating containers. What is the name of the container? You use what to use. This pod will be created, and obviously inside it, the container will be created. That's all. Got it? I saved it from my name. So now how to execute this file? There are a few commands. So one is kubectl create. This is the command. So now I have to execute the file, right? Ishwar.yml. So we have to pass argument like -f, the file. I mean, -f means the file, obviously. Create the file. It's created. Of course, before creating, usually I forgot to say kubectl config-f, right? Is it config? 1 minute. kubectl -f we can check the syntax. Modify kubectl. Okay, no, this is not. Leave it. That's wrong. My mistake. Sorry, we already created. How to check? You get pods. See, there is a pod named test running. Didn't restart it. What is the restart, please? If something wrong with the container, usually it try to restart automatically in Kubernetes. So there is no restarts. I mean, everything looks fine, it seems. Now, how to delete? Of course, you can do delete kubectl delete pod / the pod name test. But we created through file, right? You have to delete through file only. kubectl delete sorry -f. It will be deleted. Okay. This one. Let's try again. kubectl create. Yes, created. Now let's try one more time. It's already exists, obviously. That's what, right? Correct. Now let's delete the pod like this. I created the pod with the file kubectl create -f, and I deleted normally pod. You can delete like that also. That's fine. And of course, when I try to run second time, it throws an error. Let's create again. Now create with a different command. There is something called apply command. Pod is created. Get pods is running. Let's delete. Get pods. See, I can delete it. Create and apply, both are same. With small differences, I'll tell you what. I applied, correct, it's created. Get parts, obviously it is there. I'll apply again. It won't say, it won't, throw me error like, like this. Error from already exists, something like that. It's one of the main differences. If the resource already exists and you try to apply again, it won't recreate it. It won't throw error, or it won't say like it's already exists, something like that. It will try to update the existing resource. So what happens is when you do create, it will read the file, apply it. Try to create again, it'll throw error obviously. But when you do apply, same thing. It will just create whatever inside it is. And again, when you do apply, even though it's running, what happens is this will check the file for any changes. If there are any changes, it will apply the changes without deleting it, without throwing any error. If there are no changes, obviously unchanged it will be. It won't do anything. So usually everyone uses apply. For now, this is the difference. There will be few more differences. We'll see when the topic comes. But for now, the difference is same thing. Manages the resource. Similar to create, also create the resource. Update the existing resource if required without throwing the error. Just like create will throw error usually. Of course, you have seen it. It's not like bad thing, something. It's his functionality. Create means we are creating it. Apply means little different, right? We are applying a change. We might applying a change. We might applying an update. So that's usually the difference. So apply works like that. So this apply will be useful mostly because when the topic comes, there will be lots of advantages with apply. You know, we'll see later. Let's not confuse you for now. That's okay. Now kubectl delete, already. Delete minus here file name. The file name can be anything. I told you, right? Does not really matter. I'll change the file name. Nothing will matter really. That's what about the pods. Let's open a file. What is this? Test.yml file. So here what happened? We created a pod, obviously, correct? You have seen it one by one and everything. I told you, within a pod we can have one or more containers. I want to create 10 containers within the same pod. You can do that. There might be a use case, where you want to create two or more containers, where you want them to talk to each other, couple them together. So at the time, these kinds of will be useful. I mean, sorry, these kind of scenarios will be useful when you have that kind of requirement. So now how to do it? How to do? Simple. See, this is one container, right? Correct. Now you add one more section like this. That's why the section name is containers. Can be one or more. Let's copy this. Come to last. Maybe I want to create a Tomcat, so as an example. Let's paste it. This is one more container, maybe, but name should not be same, obviously. And of course, image I will be changing to Tomcat. And container port also should be different. Same port you can't use. Obviously, we don't use it. 8080. Now what happens is it will create two containers. One is for Nginx name test, and it's for Tomcat test one. Same pod. Pod is same. The containers inside are different. How? kubectl apply -f test.yml created kubectl get pods. See, it's creating 10 by 2. Remember, one is already there. I mean, it's pulling the image currently. Usually, how do I know it's pulling the image? Describe, sorry, pod slash test. Check the events. See, it's pulling the image. That's why it took some time. It took 10 seconds to pull the image. If you see any error in the pods, describe it. It will show you here. Get pods. See running. That's it. Like that, you can add n number of pods. Depends. I mean, containers depends on your requirements, obviously. So, is it clear? Is it clear about the pods and how to write a manifest file? These are called manifest files, ML files. Both. No, it's okay. You can call ML files to create pods. So we'll see what kind of errors also we'll face maybe tomorrow in the class. What kind of errors we'll see. What kind of let's try one thing now. Let's try kubectl delete -f text file. Let's read the text file. Let's just change the image name. I know its image name is wrong, right? Obviously. Let's try to run it. It's created. If you describe, you'll see the image pullback of errors. Because it can't find this image, fail to pull the image pullback of error, usually we'll see. Even if you kubectl get pod, you'll see the same error, image pullback of. By this you'll understand that, okay, the image might not exist or image name might be wrong. See, I purposely gave wrong because to show you the error. Got it? This is one of the error usually we see. Got it? One of the error. There is one more error called crash. For now, I'll just simply open the test file. I'll rectify my mistake. Now, if I use create, kubectl create, it will throw error. Hey, test is already exist. Test pod is already exist. Don't create it. But I have a change to apply, right? I don't want to recreate it. Delete the test pod, recreate again. Simply I'll use apply. What happens? It will read the file and it will, of course, check the change and see it's gone. According to the change is applied to the pod. That's how it is. See, it's running now. That's simple it is. With apply. But with create, we have to delete and recreate again. That's the case. See, isn't it easy to manage all these things? There is, yes, sorry. So that's the error I want to show you. I mean, what is that? The image pullback error. If you find, let's say, image pullback error or any error, other error, you simply describe it. It will show you the error. Mostly you'll find that. If you can't find, what do you do then? You check the log. How to check the log? How to check the container log, Docker logs, right? Similarly here, how to check container logs, kubectl logs, -f pod slash test. But if you see, it is showing only one container log, so default, there are two containers, but it's showing one container log. How to see Tomcat log? C -c you have to pass. C means containers. As simple as that. See, isn't it cool? Just very easily. I know the cluster setup might be difficult, but once the cluster is ready, the setup, everything is done, you simply play with it. Just very easy to deploy anything. Just simple. Just write a configuration ML file, I mean the manifest file, and then deploy it. If you describe it, you'll figure it out when you describe the pod or anything. Got it? That's how we create pods.
Suppose if I want to see the logs of a particular container, as you say, in the pods we can manage multiple containers,
That's
right?
what we just
Suppose.
executed. See here. Hyphen C.
Oh, okay.
That's what we just seen. Let me try again. If I do kubectl logs, it is showing to you default container test out of test and test one. That's what the container names we gave, correct? It is showing default test container logs. And you want to see particular logs,
Okay.
obviously. So like this. See, these are Tomcat logs. How do you know it's Tomcat, Catalina? This is not Nginx log. Let's try the separate Nginx logs also separately. These are Nginx logs. Like hyphen C you can pass and you can simply use this to check the logs for a specific container. Got it?
Yeah, yes. Now.
But it's cool. I mean, I'm just creating a pod, but I cannot access it. I cannot access the pod from my browser. From, I mean, to keep it simple, from outside the cluster. In Docker, we used to map the port numbers, the host port and the container port. So map with mapped port in the host port we used to access, right? But here we didn't map any port. It means we cannot access the pod. It means whatever the application Nginx or Tomcat running inside the pods, those containers, we cannot access them. How to access them? That we'll see in the next class. Got it? That we'll see in the next class. Until then, keep practicing this. First install the cluster and this one, try to deploy the pods, sample pods. Got it? Any doubts in today's class?
Not for now.
So yeah, practice it and we'll meet tomorrow. Okay? Same time, same 7 a.m. So it will now mostly it will be ours in same times. So yeah, we'll meet tomorrow. Bye, bye all.